Hello everyone, I'm G.R.K. Swami. I'm here to teach green engineering systems. Today, let us discuss some more two green building construction materials. The two materials what we are going to discuss today is lime and lime porcelana. Now let us discuss about lime. So here you can have a lime. It appears like this. It is a stone available in the earth, right? Let us discuss about lime now. So lime is an important cementing material. Lime is an important cementing material used in engineering construction or building construction. It is a cementing material, means it gives hardness or which give some packing, which is bond with some other material. Okay? So a cementing material may be defined as a material which has capacity to holding structural units, bonding or holding structural units together with sufficient strength. So you know about our natural cement. By adding that cement to the sand or granules, what will happen? The cement hold sand, granule, and everything, the brick also. So that using normal cement, we can construct normal concrete walls. In a similar way, lime also will hold the structural unit together with sufficient strength. Okay. So among this lime group, the lime, natural cements, gypsum, and the Portland cement, these are all come under this group, lime group. So these are all various synthetic products along with lime. Okay. Yeah, lime appears like this. You can naturally lime from the mines. They'll extract the lime like this. It is a white stone, and these are the pulps or tubes of lime. So yeah, while cementing material means which holds the structural unit, whatever the structural unit like brick and stones or aggregate. So like normal cement, lime also hold bricks, stones, and aggregates. Okay. So the chemical way, if you want to understand, lime is an oxide of calcium, means calcium oxide. Lime is an oxide of calcium. It is a calcium oxide. So generally, the uses of lime are using in ordinary buildings, the massive monuments, and palaces, forts, because lime appears very aesthetic and very beautiful because it is a white stone. So it is using in the palaces and forts. Okay, as a reliable and economical cementing material. So lime is a reliable and economical cementing material. Yeah, here you can have a look of how they are using lime. Lime cement here. It is a white cement. So if you join bricks with this lime, the wall appearance will be somewhat more beautiful. No? So here you can see the cement, white cement. That is a lime. Okay. So the lime is classified into three types. That is quicklime, hydrate lime, and hydraulic lime. Okay, quicklime, hydrated lime, and hydraulic lime. So from generally, lime is available in the market in three main types. In these three classifications, lime is available. Okay. So, as we are getting lime in the form of stone, that we will crush and will make into powder, and that powder will be used as a cement kind of thing. So the general cycle is limestone is nothing but calcium carbonate, CaCO3. And when it is heated, the calcium carbonate is heated, it will become quicklime. Okay, the heated limestone is quicklime. It is available in the form of quicklime. And if some water is added to the quicklime, then it is like slaked lime. Okay, and if it is carbonated, then it will again, if some H2O is removed, then it will become again limestone. Okay, so here what you have to understand is the limestone can, by burning, it will become quicklime. By adding water, it will become slaked lime, and by removing water, it again becomes stone. Like normal cement, in the normal cement, what happens? In normal cement is also obtained from a rock. Grinding will get raw cement, and the cement, if we add water, it will become stone. If you remove water, it will be, if you again, it will become raw. Okay. Fine. So here you can see very clearly calcium carbonate lime, and by burning, it will become calcium oxide plus carbon dioxide. And by adding H2O water, it will become slaked or hydrated lime. Slaked lime is nothing but hydrated lime. And by cementing plus CO2, some carbon dioxide reaction with this, it will become calcium carbonate again. So this is a cycle clearly explained in this slide. Yeah, this calcium oxide quicklime, talking about quicklime, also called as fat lime or rich lime and pure lime. So quicklime is nothing but our limestone, and it is also called fat lime, rich lime, and pure lime. So in it, calcium oxide is greater than 93% by weight, and remaining being magnesium oxide and very little clay. And quicklime is amorphous, shapeless, and white material. Okay, and amorphous and crystalline, two are two opposite and two different terms. Crystalline means in the crystal form it is available. Amorphous means shapeless, means in the form of paste it will be there. It has a very high affinity for water and carbon dioxide. Okay. Fine. Yeah, this I already explained. The calcium oxide plus carbon dioxide, calcium carbide will come, and calcium oxide plus H2O will get the hydrated lime and all. We already explained in the previous slide. Why to confuse you? Okay. So manufacturing of fat lime is not in your syllabus. So quicklime is like this, it appears, and limestone will become quicklime plus carbon dioxide. Okay, that is all hydrated lime composition. Okay. Hope you got about lime. So here in this picture, you can see that here you can see lime using as paste in the construction of walls and all. Okay. So yeah, not necessary for you. The hydraulic lime, we have class A, class B, class C, class D materials, and in the class A, it is 21 to 30% clay content will be there, and it is set under water in 24 hours. And moderately hydraulic clay, 11 to 20%. Clay content will be 11 to 20%, and it sets in water about a week. And feebly hydraulic, class C, clay content 5 to 10%, and rich in magnesium, suitable only for finishing coats, finishing purpose, plasting purpose. Okay, do not versus hydraulicity. What is hydraulicity? The capacity to set and harden even under water and in the absence of air as between very thick walls. Means hydraulicity means the capacity to set harden. So generally why you apply cement to make it hard, right? So the capacity to set and harden even under water. Even you add water also, it has to become harder. And in the absence of air, as between very thick walls, means absence of air. When inside the bricks you join using lime cement, so air is absent there. There also it has to get bond and it has to become harder. Okay? That nature is called hydraulicity. The hydraulic lime is further classified into three subtypes as we explained just now. Okay. Fine. So lime is also classified into these many types: class A, class B, class C, class D, class E, and F. So class A is eminently hydraulic lime. Class B is semi-hydraulic lime, and class C is fat lime, and class D is magnesium or dolomite lime, and class E Conker lime, and class F siliceous dolomite lime. So actually these are all classifications just for knowing. If you remember, you can write in the exam also about lime. So as I told that engineering concept is that there is no end. Means at a bachelor level, degree level, BTech level, how much information you want to know? No, as per the exam point of view, or no as per the syllabus point of view. Okay, about line, if you want to talk, we can talk for many hours, many classes also. Okay. So this line can be used for structural work such as arches, domes, etc. And it can be used for constructing masonry, means rock and rock materials, and can be used for finishing coat in plastering. Yeah, in plastering you can use and whitewashing, etc. Used for masonry mortar with the addition of pozzolanic material, and can be used for finishing coat uh, in plastering and whitewashing. Okay, and produced by burning lime nodules found in soil like black cotton soils contain silica. It can be used for masonry mortar and pestle means rub roll ఉంటాయి కదా చిన్న చిన్నవి. So small items, mortar and pestle. So mortar preparation also, this limestone prepared mortar pestle is available. Mortar pistol అంటే రుబ్బు రోలు. Okay, small quantity in pharma labs or in labs they use mostly. It is used generally for undercoat and finishing coat of plaster. Okay, so this is a general classification of lime, uses of lime. Hydraulicity we already explained. Okay, so classification, further classification, lime has also sometimes classified on the basics of raw material, means type of raw material. It is a stone lime, shell lime, and conker lime. Yeah, in the previous slides also I told conker lime. So similarly, lime is distinguished into building lime and finished lime. Okay, instead of stone lime, shell lime, and conker lime, lime is also classified into building lime and finished lime. So lime, generally, construction of walls, in between the brick to brick, you apply cement. Similarly, for plastering also you apply cement. So lime also in the same way it is used. Okay, for constructing walls and as well as for plastering, finishing lime. So that is building lime and finishing lime. Okay, so the first type, the building lime. Building lime, less water content is added, so it will become little harder and it will give more bondage. So in plastering purpose, we use more water and similar way, like our normal cement, lime also using. Okay. So finished lime should have plasticity, and it has to deform when you apply some pressure. Okay, using tapi, you pour on the wall, and you have to deform the paste kind of material like normal cement. Hope you understand. Okay, so this lime is having, the finished lime is having good plasticity and good color and quick setting property. Okay, and here you can have pictures of this is a stone lime, and this is a magnesium lime in the powder form, and this is a shell lime, and this is conker lime. Okay, so these are all limes using in for various different purposes. Okay, that is about lime. Actually, lot of matter is there, as I told, master's level and all. So far, what we discussed is enough for the BTech point of view. Lime. Okay, that is about lime.